Hello guys, good evening. So how was yesterday? Did you practice there? Yeah, today, yesterday of course we did starting from uh, surface creation up to the horizontal alignment, and today we are going to try the profile creation. And
Recording in progress.
yeah, yeah, so today we are going to discuss on the profile creation, and then if we have time we'll try some cross sections as well, because the cross sections are very important when it comes to rehabilitation projects, because only with you know now with civil 3D, of course. Now yesterday also I told you that it is kind of an application software that helps you or assists you to do the highway design. But you have to do your alignment as well as the profile. But the problem is, now you see, now when it comes to profile designing, the biggest worry as an engineer is this fill. Now, there was a time that people asked whether the roads were built with gold. Why? Because the materials are that much expensive. So, as an engineer, it is your responsibility to economize the design. That means to reduce the fill as much as possible. That cannot be done only with horizontal alignment and profile. So, you have to create some cross sections as well. So, I'll be teaching how to do that. We'll quickly finish this profile and then super elevation. I'm sorry, I do not have time to cover the super elevation theory as well. But please understand, now in Sri Lanka we are using Ostro's method. So I'm not sure what you are studying in university. Maybe it is ASHTO. ASHTO we are using only for this expressways, right? For the national roads we are using Ostro's method. There's not a much big difference between the two, but the problem is, in ASHTO you have super elevation development length is divided into two parts like runoff and runout length. Now in Ostro's, we don't call them in that jargon, so in that terminology. Instead, we have only the super elevation development length. So we calculate super elevation development length, and then we put one third of the super elevation development length inside the curve, and the other two-third outside the curve. Okay, why I told that in the beginning, otherwise in the course of the lecture you will be confused why he's doing like this. Okay, so it doesn't matter. So anyway, even if you want to do ASTO, that is also possible. Okay, no harm, because Civil 3D is a common platform, so you can do either ASTO or STO or British Standard or whatever. Okay, so now yesterday I asked one of you to send me an email or WhatsApp to send you my book. Why I ask you is because within 4 hours I can't cover everything, but in the book there is everything. So, but nobody sent, right? So today please send, right? And I have uploaded this video into YouTube also, so you can watch uh, just by searching, or I can send a link also, because now don't think it is a dollar earning or something. I don't earn any dollar. The only thing is that most of the people are benefited, so that is why I just uploaded. So you can also watch in your free time, and then whatever you are missing in this lecture, so you can uh, get a good understanding. Okay, so I'll show you. This was the small booklet that I wanted to give you. Now here with the surface creation. Okay, surface creation. So this is the same example I have taken. So here I am describing step by step how you are going to do that. So you can get a printout of this and keep with you, because it is Civil 3D is not just an assignment. If you join Road Development Authority or highway sector, that is really important for you. Okay, so that you can practice at home, right? So we'll go back to our lecture. So I'm going to open our alignment that we did yesterday. Yeah, Civil 3D. Yeah. Give me a second. Right, so this was the alignment that we did yesterday. Now all the steps that I am going to discuss here are there in that small booklet. Okay, so please send me an email. I'll send you the book free, so everybody can share among yourself and take a copy. So when you are doing your assignment, that will be much beneficial for you, right? Okay, so now this is our alignment. So we have completed alignment up to yeah, around 1 kilometer. Okay, so now today we are going to create our profile. Okay, profile is this is in horizontal alignment. We are telling what are the points that we are going to put on this put on the ground horizontally, and when it comes to profile we are going to tell them what is the level that you have to put your road surface. Okay, so the first thing that we are going to do is we are going to get a copy of this, saving this as profile. So I'll put that into day 2, profile, and save. Right, now creating the profile is actually very easy. It is just like using this one, profiles, create profile from surface. Now you see there are so many tools here, but we are using create profile from surface. Okay, so now here comes this alignment is DCL, select surfaces, that is EG. So that is the only surface that we are having, so we are going to add that. What is DCL? That is the alignment that we created. Okay, EG is the existing ground that we 3D model. So we are going to add this existing ground into this alignment, so you can add, right? Then press draw in profile view. Then it says alignment is DCL. So the profile view name usually we give EG, and profile view style we give this is. Now you see there are three options: full grid, profile view, PV style, 1000. So that is the one we use. But if you really want, you can have a say, you can either edit the current selection or create new, or copy current selection and change one of your own. Just think that if you want to have a one for your university, then of course you can have a say create new or using copy current selection, and then you can change whatever you want and have one template for your university as well. Okay, so we are having what we are usually having, PV style 1000. Then you go to next, and station range it says 0 to 1 kilometer. Now why it is there? Because sometimes maybe if you are having 50 kilometers, yeah, it is not very proper to have the profile view from 0 to 50 because the capacity is high. So if you want, you can use this user specified range and then you can change it. Okay, and but we'll keep it here as it is automatic, right? Then press next. Okay, then profile view height, that is also we are not going to change. Next, and then here we have profile display option, and then select band set, that is RDA PV band set 1000. Okay, then press next. The profile hatch options we have nothing to do, so you put create profile view, and they say select profile view origin. You put somewhere there is space. Okay, then this is the existing profile. Okay, so this is the existing profile. Now we have to create our design profile. Existing profile is, that is how, now you see, if you go to 0, that is the level you are having. If it is 20, this is the level you are having. If it is 40, this is the level you are having. Now you can see finished ground level and existing ground level both are same. The reason being that we have not we have not changed the change, in the sense we have not designed the uh, profile. Okay, yeah, right. Then, so I'll discuss this first. Okay, this is the station 0. Now if you want, you can have this as 10 nodes. So how do you do this? You select this here. Now there is a method of selecting. Don't select it like this. Okay, then it is only the profile view is selected. So you have to select it like this. Then you can right click, go to say profile view style, and then you say here under horizontal axis major tick details are in 20-meter intervals. Okay, then you can, if you want, you can put 10 and see what is the change that is coming. Okay, now in 10-meter intervals you are having the levels. Understood? Now then the finished ground, because we have not designed, so it is the same thing as existing ground. And vertical geometry, the geometry in the existing road, that is wrong, right? Because we have to give the design one. And then the super elevation, of course you have to give the super elevation. In this band you have to give the super elevation, right? Now guys, there is one thing I have to tell you. In in Civil 3D, there is an option called automatic super elevation development. Never use that. Okay, this is kind of a bug. Why? Because when the Autodesk people are coming, also we are telling why we go. No, it is not a bug at all. But the thing is, it does not consider. It does not consider the reverse curves and these compound curves. It is treating every curve, as a you know uh, single curve. So that means, so it is doing it like this. It calculates the super elevation development length, say 24. Then you can select whether it is Astro or Ostrots or whatever you can select. Just think that we are going for Ostrots. Okay, so if it is 24, then you have to have 8 meters inside the curve and 16 meters outside the curve. That is understood, right? So for 2.5 super elevation. Then, okay, here in this curve, it's okay. 8 here, sorry, 16 here, 8 here, so it draws. And at the end also it is okay. 8 here, 16 here, finish. Here also it will be okay, but now when you are coming when you are coming here, it is going to draw a super elevation diagram considering this as a single curve, this as a single curve, and this as a single. I'll show you how it comes, but that is wrong, right? So if you want, I'll show you. You can go to general tool space, and you go to this alignment, no, sites. It is inside design. Our alignment is inside design. You remember yesterday we put that into side design. Center line assignment DCL. You right click it, edit super elevation. Okay, then calculate super elevation now. Okay, so it is undivided ground. undivided means you don't have a center median. Okay, so you can press next. Say normal lane width. Our normal lane width, usually when it comes to two lane roads, we add our hard shoulder also. Okay, we add our hard shoulder also. So it is 3.5 lane width and 1.5 hard shoulder, so that is 5 meter. Normal lane slope is minus 2.5. Okay, you go to next. And here they ask normal shoulder width. Normal shoulder width, usually we give that is yeah, we say it is 2 meters. Normal shoulder slope, that is minus 4 for uh, soft shoulders, right? So you go to next. And here they are asking this is maybe they are using Ashto method, right? Ashto method. Here you don't have Ostrots. Okay, so we'll just for the deliberations we'll use Ashto method. Two lane. These of course you can change on tangent curve. How much superelation development should be there on spiral for spiral. So this is correct, right? This is according to Ashto. So we'll finish it, and now you can see here. Now you can see. Now this one is pretty okay. Okay, it's 4%. 4% because we haven't set the the design speed. Okay, so you have to set the design speed here. Sorry for that. You can go to say properties, masking. Here design speed is 100, so we'll put that into 50. Okay, apply and okay. So here super elevation also maybe it will have to be changed here everywhere. So it's 50, no? Yeah, so that is sorry. So the thing is, so we'll put recalculate. Now you know what happened. So the thing is that depends on the Ashto, right? Not the table that I showed you. That is Ostros. So now, okay, anyway, this is correct, right? According to Ashto, this is correct. And then this is also correct. But now you see what is happening here. So they are considering everything as a single curve. Now look, this is a mess. Okay, why? Because it is developed with the super elevation for that curve, super elevation for this curve separately, and super elevation for the third curve and fourth curve, and it has become a mess like. Okay, so you cannot use that for your super elevation development. So what you have to do is either you can do manually, or in our office we have developed a small Excel sheet, but I think I better don't give it to you because that is for some commercial purposes. But when it comes to students, of course, you should know how to calculate your superelevation. Otherwise, it is just automatic, so you don't know how to calculate. So I will remove this superelevation from here. Okay, so I'll go to sites, site design, alignments, center line alignment, DCL, and I'll right click here and go to edit super elevation. I'll go to tabular editor, and here there is some like a loaf of bread, and there is a red color cross. And I'll show you before that. Here Civil 3D has itself identified that these are wrong. Okay, so I'm going to remove everything. Now look, it's not there, right? So I will tell you how to manually insert super elevation here. Okay, so now since we do not have time, I am not going to calculate anything. I'll take super elevation development length as 24 meters. Okay, so for one or two curves I'll show you how to calculate, right? So yeah, but the thing is, if it is 100 meter, it comes 3, right? So you will have to calculate it yourself. But anyway, okay, we'll try our best. Right, so we'll go to uh, edit super elevation. Instead, calculate super elevation. Now we'll go to open the super elevation curve manager, right? Then you will go to tabular editor. You know there is one curve, curve 1. So you can insert add station, right? Now you know, even though there is no super elevation, there is normal cross fall, but we have to add, okay, we have to add uh, minus 2.5 here. Why? Because that is the normal cross fall. Now usually what we do is we put minus 2.5 into 0, and then we go to this last one, and then we put minus 2.5 to both ends. That means to the LHS side and RHS side. Okay, so then what happens is it draws the super elevation. Ah, 1 minute. Students request the drawing file used in the lecture. Can you please send them to with the book? Ah, yeah, sure, I'll send. Okay, I'll send. So you can get practice with that, right? Because that is the same thing that I have used in the book also, right? Okay, so then, right, we go to tabular editor. Ah, yeah, sorry. Specify station along baseline. So I'll put 0. Okay, so here comes, there is curve 1 transition in region. Here there's a manual station. Why? Because I add it manually. So you can right click on that and assign critical station. You check whether there is a begin alignment, begin full shot. No, it's not there. So we'll just put begin normal crown. That doesn't matter, right? It should be begin alignment. If it is not there, we'll put begin normal crown. Then I have to give here, if you don't see these things, that is left outside shoulder. Now they are talking here about the paved shoulder. So usually in Sri Lanka, we are having the paved shoulder with the same slope as the uh, what you call this lane. So it should be minus 2.5, right? Minus 2.5. Again, I'm going to tell you something. You just pay attention. Once I take it away, look, it's not coming. Okay, that is again another bug we are having. So what we are going to do is we tick it and then come back, right? Then I am going to do it minus 2.5, right? Then okay. Then left outside shoulder. Then here they are asking left outside lane. Okay, that is minus 2.5. And then here left inside lane, that is also minus 2.5. Left inside lane, that is minus 2.5. Sorry, left inside shoulder. Right inside shoulder, that is also, if you want you can copy also like this. Control C, copy. Right inside shoulder, Control V. Right inside lane, Control V. Right outside lane. What is this inside lane and outside lane? That is if the road is 4 lane. So you will ask me why you are inserting for the inside lane and right outside lane. Because when it comes to cross section, that is necessary. That is why I put, otherwise there is no need of course. Right? Right. Then you can check this and see. Here it has come to minus 2.5, but here what has happened? It has come to 0. So we'll insert this one also. 1044.944. So I'll go to the last curve and I'll uh, add station, say 1044.94. Don't give to the third decimal, okay, because sometimes it doesn't take, that's why. So here transition out region, manual station. Here also I'll assign a critical station like N normal crown, right? Then this should be minus 2.5. So maybe that bug is again coming. Yeah, it's coming. So you have to check it, come back and give minus 2.5. So you can copy this and you can paste it. Here I have forgotten right outside shoulder. Okay. Now check. Now it has come here. So I'll calculate super elevation for this curve, right? Because it is minus 2.5. Otherwise, you will have to. Now I will insert super elevation here because otherwise you will have to calculate that. So we don't have time for that, right? So I'll take super elevation development length as 24. Now according to our store, according to our stores, it is super elevation development one third inside the curve, two third outside the curve. Right. So take this end of the start of the curve. It is 345.402. Now in real practice, we ignore this what the decimals. Or ignore in the sense we are going to uh, take it into the nearest integer. Okay. So since this is lesser than zero point 0.5, I am taking this as 345. Right? Then you have to deduct 16 meters away from this one. How much is that? 329, right? So in the third curve, I'm going to insert at the station. Now it is 329. In 329, I am going to end the normal crossfall. That is where the superelevation starts. So I'm going to add assign critical station end normal crown. So I'm going to end the normal crown. So is there any difference in super elevation there or the crossfall? No, because that is the point that I am going to finish there, right? Then I have to add 8 here. 345 8 is 353. Okay, so I am going to add another one. Add station 353. So here it comes. Assign critical station begin full super, that means it is going to start full super elevation. Now if it is not coming, it's again you have to go there and go to tabular editor. Here begin full super 353, right? In begin full super, you know this curve is turning this side. Okay, so what should be super elevation side? That is right hand side. Okay, always check you are coming from here to here, then this side, now it is turning this side, so your super elevation should be RHS. So you have to put plus 2.5 to all the R right hand side values. 2.5. So I'm going to copy and yeah, we'll see again. Sometimes it stucks. Here 2.5 right. Here this one also plus 2.5. Now see it's come. It has come like this. Then end. End is, you know, it is 409. You have to deduct 8. That is 400, 401. So here again you are going to add station 401. Now it's manual station 401. That is end normal. Sorry, end full super. So it should be the same thing as this. So I'm going to copy here in right hand side. all the right sides should be plus 2.5, right? Now it is also drawn, and you have to take, say, it's 24 that I have taken as the superelevation development length, so it is 425. Okay, so what I did was, this is from here to here 8, from here to there it should be 16. 24, but you can just calculate 401 plus 24 is 425. So you go there and then you add another add station 425. Okay, and then it should be all minus 2.5. So yeah, before that, manual station, assign critical station, begin normal crown. Normal crown is going to start again. Okay, so maybe again you have to take it like this, begin normal crown. So everything should be minus 2.5. Copy this and you can paste here. Quite tiresome, right? I know. That is why we have developed a small software, in the sense a small Excel sheet for that. Okay, so with that you can automatically do, but as students, maybe you may have heard that you have to know the law and then break the law, right? So this is the superelevation diagram for this curve. Okay, but if it is a like now just tell me, if it is a compound gun, what happens if that is always 2.5? So
Recording stopped. Recording in progress.
yeah, now if it is super elevation development is I mean the super elevation is always 2.5, so you have to put the super elevation like this, and then you have to continue for all the compound curves, and in the reverse curves. So this level crown, what do you mean by level crown? This point, right, where it is getting 0. This level crown should be here, because sorry, here, because it changes the direction. Okay, this blue color line and magenta color lines change the directions. Okay, so that is about super elevation, how you can insert, and in that my small booklet everything is there, including the jargons also. So you may be able to check what they are telling by, say, end normal crown, begin normal crown, level crown, what are these things, because the civil theory is using some jargons. Usually that is not used in our normal highway design textbooks. Okay, right. Now guys, any questions? Yeah, if you have any questions, please ask me right now. Because you know that I don't want to be that old man from the industry that who came to do a lecture and you didn't understand anything, right? So please ask me if you have any questions. Otherwise, we'll go to the next section, the profile. Maybe you are not having problems. That's the thing. The thing is that you haven't understood. I understand, because you see this is a big software. You cannot grasp it very quickly within 1 or 2 days. You will have to do your own practice. So maybe you can practice and then ask me questions later, but still if you are having any question, please raise your hand. Okay, then shall we move into the next section, the profile view? Right, then profile view is, of course, please understand what do I mean by profile. The profile view is usually what we do is, now this is the existing profile, right? We are going to smooth this as much as possible. Okay, we are trying to smooth this as much as possible and ensuring that our design standards are maintained. Now again, please give me a second. I'll show you the values that we are going to use. Yeah, vertical alignment. Now, guys, because if you have studied AASHTO standards, now these values may be different, but the theory is same, right? Because these are coming under the research. So uh, Australian values are different from that of the American values and Canadian values. Why is that? You know that Australia is quite of a desert country, and they do not have much of a snowfall. So therefore, their values, just like the friction values and their visibility and things, are different from that of America and Canada. Okay. Now, if you just check the Canadian friction values, they are quite less compared with the Australian values. That is why we are using the Australian values in Sri Lanka. Okay. So now you see, if you are going to design for 50 kmph, our k value, to ensure, now this there's some small mistake here. This is stopping side distance and this is continuation side distance, and this is overtaking side distance. As I remember, in AASHTO there is some difference that they don't call it continuation side distance, they call it some other word. Do you remember, anyone? It is not continuation side distance. Or overtaking side distance is different. I don't remember very well because we don't use usually ashto. There is a different word, right? But anyway, the same meaning. So okay, so this should be SST, this should be CST, and this should be OSD, right? So here, if you are going to have, this is for crest curves, right? If it is a crest curve, the K should be 9.8. Remember that, right? Then you see appearance criterion for 50. Maximum grade change should be 1 and vertical curve length should be 50. Now remember, keep a mental note that we are going to assign only 50-meter curves, right? And if our, this the gradient difference is lesser than 1, you don't want to have a curve. But I personally do not advocate for that. Maybe the books can tell anything, but if you are going to put it like that, what happens is, in the road there is a kink. So usually we jokingly call it night ride effect. Night ride effect, in the sense, if the vehicle is going in high speed and if there is a no curve but there is only two gradients, what happens is, you are just like, you are just getting a feeling like a high jump. Okay, those who are in the back seats, they just jump themselves at the back seats. That is, we call, there's nothing called night ride effect. We jokingly call it night ride effect. So we as designers do not usually advocate for maximum grade change without vertical curve. We usually say wherever we are going to engage a vertical curve for smooth transition of grades. Okay. And then based on the comfort criterion, you have to have 6.5K. If you are going to give 9.8, this is automatically uh, satisfied, right? And now we'll go for sag vertical curves. For the sag vertical curve, for 50, you have to have minimum 12K value. Why there's a difference between sag and crest? Because this is based on the headlight criteria. Okay, now if you are going to give 12, this comfort criterion is same for all. I'll show you. Appearance, comfort, drainage, other all are same. Only the side distance is different in sag curves. Therefore, now if you are going to give 12, all others are satisfied. Okay, so the dominant factor here for crest and sag for the speed of 50 is side distance. So remember, for the crest curve it should be 9.8 and for the sag curve it should be 12. Okay, with that in mind, uh, we'll go to design this. Okay. right? Then we'll go to here, profiles, create profile. Now earlier we went to create profile from surface. Now we are going to create profile by layout. Okay, select profile view to create profile. So we'll select a profile view. It is this one. Now it says this is the alignment that it is based. Name, usually we give FG, finished graph. Okay, so the profile style should be RDF finished, but if you are having now here also you can change it if you want, create new, copy current selection, edit current selection, whatever, and then you can have one for your university as well. So I think you guys can create a template for your university when you pass out. Okay, so your other juniors can use that, right? Profile label set, usually we give finish profile design parameters 2, right? Press OK. Again there comes a profile layout tool. Okay, so using this toolbar we are going to design our uh, the profile, the finished profile. Okay, so we'll start doing that using profile layout tools. You have to get this draw tangents, and with OSNAP on you can select. Now remember, I am going to smooth this as much as possible. After that, you know what I am going to do. Then I am going to raise that profile by, what is the value that I have to raise it? By the payment design. Now I'll assume, because of course the payment design has to be given, I'll assume it is, say, we'll assume like this, wearing cost 40 millimeter and binder cost 60 millimeter, so that comes to 100, and say our ABC is 200, so that is 300. And do you want to have soil? No. Why? Because this is an existing road, we are not going to dump soil on the existing road, so it should be only 300. So what I am going to do is I am going to match this my profile view as much as possible to the existing one, and after that I will raise it by zero point 0.3 meters. Understood? Now I am going to put the, as same as the alignment, I am going to put IP, we call it PVI. PVI means points of vertical intersections, right? We are going to call it PVI, points of vertical intersections, and then we are going to you know uh, after putting the points we are going to employ curves there, right? So when you are going to put it, remember your curve length is 50, that you have to put that in your mind, right? If it is 50, definitely the length difference between two curves, so not two curves, two IP points should be greater than 50. Understood? Otherwise you can't have. So you will understand when I'm doing that, right? So just think that what I'm going to do is I'm going to match it like this, and then maybe I'm trying to have an IP here, then there, and there. There are other things that you have to take into consideration, right? In the course of our design I'll be telling. What is that one? What about the minimum gradient? For a national road the minimum gradient should be 0.3, right? That is another constraint. Otherwise what happens? There will be drainage problems, right? Right. Then here I'm going to correct these things. Now using this properties table. Okay. So I haven't touched this properly. It is 0.036. So I am going to make into 0. right? And you know it is 25.2027, so that is also okay. Now look what is here, it is 0.18, right? We cannot have 0.18, you have to have minimum 3%, so you will have to make it minus 3%. Now what happens? Now it is going to cut the existing road, so that is not possible. So maybe what I am going to do is I am going to put a curve here, so IP here, and I am going to say I will try to raise this by, say I'll put 0.3 grade out. So maybe it will work, we don't know yet. Anyway, you can change later. Okay, now it is minus 0.3 plus 0.3, so I will put a free vertical parabola curve. Free vertical parabola curve. Okay, I'll select this one and then go here. Specify curve length of pass through K. We are giving here the curve length 50 and press enter. Now look, now it seems quite okay, right? Then you know what will happen if I put the 50 here. We'll see what will happen. Now you just have to, now you know earlier you selected this more free vertical curves, free vertical parabola. Always you don't have to select. Once you have selected, you can just click it here and here. Before that, you know usually we have these PVI points in integers. Okay, not in decimals. These are some good practices, right? So you can't say right or wrong, but uh, these are some good practices. So I'll use here 120. Okay, then I'm going to put 10, sorry 15, 50. Look what happened. It's not going to work. But depending on and depending on these configuration, you can change these IPs like this. Here move IP. Or like this. Okay. But remember again, this should be minimum 25 meters. Okay, so that means effectively from 120 to here it should be 50. Why? This is the length is 50. The length is, you don't, you know, in vertical alignment you don't measure the length along the curve. You measure it along the horizontal plane, right? That is what is given, right? So it should be, yeah, 170 is okay. And again you can see here this IP is not necessary, so you can remove it. Say like this. Yeah, so another thing that you can do is you can increase this curve length. Here profile curve length is 50. I'll go for 80. Look, it seems legit, right? Then if you are going to have 80 here, of course you will have to remove it somewhere here. No, it's not going to work like that. So maybe what we can do is we can make it 50 itself, right? And then if it is 120, so it should be 50 means yeah, 177 is okay, but we'll make it to 170. And we'll lower this. It is 25.148. Say we'll put 25 or 24.8. It seems okay. And then try. There is another problem here. What happens? 0.13. So that is not possible at all. So it should be definitely plus 3. So that method is not going to work. It's a trial and error, right? There is no there is no something like that in one shot you can't do. That is why I told that is an art. Now before going further, we have to correct some of the things in this profile view. What are these things? Okay, one thing is you have to give the finished ground levels, you have to correct them, and vertical geometry you have to correct them, and then you can have for a guidance you can check what is the difference between the existing one and the finished one. So we'll correct them, right? So one, then what you are going to do is you select this profile view, go to profile view properties, and then go to bands, and here you have to change station value, that is EG surface is the one that you have already created using the surface data. You remember only the using the surface data you created a surface called EG surface, that's there. And then they are telling finish road level, so that should be the one that you are designing now, should be FG. Okay, both should be FG, right? And then existing ground level, it should be EG surface, there should be no change. And then vertical geometry diagram, that is FG. So that means that they are going to uh, show the finished ground level. That is all that they allow you to change. You apply it. Now check, right? Now see here, these are different, right? So here the finished ground level is lesser than that. That is not possible at all. Here it's been cut. So you will have to change them definitely. Okay. And shall I show you another mishap? Here k is 6. For a crest curve, I told you k should be greater than 9.8. So you can't have that. Okay, because you are designing it for 50 kmph. Right, so how can you increase the k? By increasing the profile curve length. Say I'll put 80. Now I'll check what happens. K is 9. Now this is not going to work. So I'll remove this IP. Right? Instead, I'll put an IP somewhere here. We'll see what's happening. Okay. And now K is okay, but there's a heavy fill. But I can reduce the fill by taking this here. Okay, understood? If I take this IP here, this fill will be reduced. Right? Now, we can't do miracles, right? If there is a fill coming, the fill comes. Okay. Why? Because we are going to design an existing road into a standard road. So there may be fill coming. We don't know. But if there is a method that we can reduce it, we should be able to reduce. Alright. Then again, I want to tell you there is a simple method that you can check the difference. You select this one, go to profile view properties, and there's something called elevation stations. Remember, you add this one. Okay. And here you don't put 12.5 in the gap, you put something like -100. And then here profile 1 you put FG, profile 2 put EG, and then press apply and check. Here they are giving us the difference. So if 100 is a problem, what you can do is, say you can go to here 100 and say 120. Right. Now it is showing us what are the changes that we have to do. Okay, right. Then you can move. Is it disturbing? I don't know, maybe you don't see it, so we'll put it somewhat high. Now okay. Right, now we'll try to move this here. This is 40, so if it is 50 meter curve, here comes 25, this is 80, so there comes 40, and 25 plus 40, I'm talking about the half values, right? 65, so this should be 105. So let us take there 105. But again you have to check using there what is the grade out. It is 0.37. Then okay, right? And again remember there is some in this value always you can't put 0, then there is nothing to design, right? So we are going to give some uh, some clearance like -10 or +10. Okay, there is some uncertainty, so we'll put if it is lesser than 20 minus or plus 20, that is okay, right? But in filling areas like this, of course you can't do anything. Now can you see that because the thing is now this road was earlier not designed for 50 kmph, maybe for 40. Look, what is this one? So the vehicles going there, they are unable to go at 50 kmph. Why? There is a like a dip like thing like here. Okay, so we'll take this into 210. Check your K, right? K 16. Okay, here 75. Okay, right. So you take it there 210, and here in the here the gradients are okay. So we'll put 50. Now there's another bug, right? This not showing. So if you want to check, you can go to profile view properties and again apply. Here it shows K is 70. That's a sag, right? It should be 12. Okay. And now the gradient is okay. I don't think this PVI is necessary. What happened? So I'll put it this way, and maybe I will have to have an IP somewhere here to make it minus, sorry, 0.3 here, and then maybe I'll have to change somewhere here. We'll see, right? Yeah, here I'll put that into 280 just for the aesthetics, right? Aesthetics of the design, right? Then I'll put 50 here. If I want to check the K values, I will apply and check. It is 28. This is a sag curve, so they are giving us a K value of 28, then that is okay. Here 3, we'll make this 360 first, right? Then we'll put 50 here and check. There's going to be a very high fill, right? So we'll have to correct that. We'll check whether it is possible to correct that. If it's not possible, we can't do anything. Okay, we'll try to take it here, and we'll try to put something here. Okay, seems okay. We'll see. Then this should be 430, and we'll put 50 here, and we'll make this 480, and of course we can, it is 0.68, shall we put 0.3? It's coming like this. So let us make this 480. It's okay. 0.3 minus 0.33. So okay, we'll put 50, and here we'll take this into 440. Yeah, these are okay. We'll put 50. Later you can check the case, right? And here we'll take this as say 610. That depends on your judgment, right? Right, we'll put 50 here, and 35 54, that's okay. So we'll take this into 695, and we'll put 50 here, and here 763, we'll take that into 760, right? Then we'll put 50 here. You will have to raise this, okay? 7247, we'll take this into say 820, 820, and then I'll put it 50. Okay, then I'll take this into 900, and then I'll put 50 here, and the last one I'll take this into 990, and I'll put 50 here, right? So I have to take this into the existing ground to 20.154, right? Then if you want to check your K values, you go to profile view properties, apply, and then now start checking K. Here it's a crest curve, 16 is okay, minimum should be 9.8, sag curve 16 is okay, it's 12, sag curve 28 okay, crest curve 50, sorry, it is 44, sag curve 44 okay, crest curve 81 okay, crest curve 198 okay, sag curve 54 okay, uh, crest curve 54 okay, sag curve 37 okay, 157 for the crest curve okay, sag curve 57 okay, crest curve 23 okay. But now we'll have to check where we can change to reduce the, to get the minimum, what you call the minimum fill. Here it is something like 84. So and here there is no influence from this, what you call the gradient. So we'll try to reduce this. It's 84, right? So we'll go to give this 350, 20.350. So now K is okay, should be greater than 12 only, and the gradients are okay. Here if you want you can reduce something more, but I'm not going to into that much of fine corrections. Okay, so here it's okay, this range. Here of course you can't do anything because you have to keep this, what you call this minus point, sorry, this plus 0.3% should be maintained. So there's nothing you can do here. Of course that is in the range. Here now the problem is, we'll here 68, it's too much. We'll check what about here grade in is zero point 0.3, so you can't change this. Okay, very sorry. And here of course you can, but check the here again there is grade D, then you can't. Here that is in the accepted range, but here you see it is going like 0.64 something, so that is not very nice. So you should try to correct them. Okay, we'll try to correct, so at least we'll give 60 and check what happens to this. It is 27, right? So you can't do that, you have to give minimum 0.3, so that is all you can do. Then it is 55, right? Here lesser, right? So you can say we'll give another 50 and check what happens. Oh, it's 29, so you have to give minimum 30 here. Point 0.3, right? What I'm telling, 30 is as 0.3. Okay, yeah. Now here, of course, you can increase this, I mean raise this. Should be something like 100, right? So we'll go for 650 and check. 4364, that is okay. K is okay. Here what happens? Here you can reduce something like 100. We'll go for 3. Yeah, then there is a cutting here, right? Cutting here. So you can try. It's too much cutting, right? 82. So you can try when you are going to do that. How you can try? One thing is you can change this eyepiece and check what is the best solution. Here minus 0.23, but anyway that's okay, right? So just think, because I can correctly do that now. The thing is, now this is almost done, but of course I have to fine tune it, but because I cannot design a 1 kilometer road within say 1 hour. Then why are they going to pay me? Okay, so it may take some 2 days, 3 days, even with the civil 3D, because civil 3D is not telling us what to do. We have to tell the civil 3D what to do, then it does. Okay, so you will have to try to fine tune this road as much as possible. Once you have finished that, our payment design is 300. So we'll go to say here, this one, I think. Raise lower PVIs. I'll raise it by 0.3, 300. That is the payment design. Okay, so our profile is completely finished. Okay, our profile is finished. So you can save the drawing. Right, we have completed the profile view, and now we have to make cross sections. Now before that, you have to have some more alignments here. We are only having the this design center line and 2 offsets only. So you will have to have another offset alignment calling hard shoulder. So we'll put that into offset alignment, offset name template, whatever later we are going to change. Number of offsets on left, it is 1. Number of offsets on right, it's 1. Incremental offset on left is 5 meter. Why? 3.5 is hard shoulder, and then 1.5 is, sorry, 3.5 is lane width, and then 1.5 is hard shoulder. So when you add them together, it comes like 5. Here also it's 5. So alignment style, RD design style, we don't want labels. There another 2 are coming. You can change their name. Alignment properties, you can it is DCL left 5, that's okay. Here what is the name they are giving? DCL right 5, that's okay. But if you want, you can change. You can give here, usually we put H LHS. Okay, that is hard shoulder LHS. Here we put H RHS and apply and okay, right? Now everything about this one is finished. Save the drawing. Now I'll tell you one thing, when it comes to the cross sections, you cannot use this template. So I'll show you another one another drawing that we have created very beautiful cross sections. Okay. So what are we going to do this for this blah 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 blah? We are going to continue with the current command. So if there is any reference, this is because open the external reference we don't have. Therefore, we ignore unresolved references. Now, can you see here how beautiful it has come? Okay. So this is some 4-lane road. You know this is the existing road, and after that there is a fill in, and then you have the drain and the raised foot top. Okay. And their ABC is showing like this, and this is the soil. So this is very beautiful. Okay, so we are going to use this drawing. We are going to use this drawing for our cross section development. For that, you have to delete everything in that drawing. Now I am going to tell you how to make a kind of template, right? So what you are going to do is you are going to delete everything in this drawing. I selected everything like this, and then I press delete button, right? But that is not finished. You have to go to tool space and check under the prospector what is left from this drawing. Here there's something called service reg. So sorry I'll right click that on that and put delete. Are you sure you wish to delete? Yes. And then alignments, there are no alignments in this side. Sides, check whether there are sides. Yes, they are, so we'll delete them. And this one also delete. And assemblies, of course there are no assemblies. Survey, that's nothing. So I'll put a command here, purge. That means all unnecessary layers will be gone. Purge nested items, everything. Okay, purge all items, then close. Right now this drawing is blank. Now I'm going to save it as a template file, save as, and once I change the files of type into template, here drawing template, it goes to the area, it goes to the folder that templates are stored. So I'll go to this UOM and I'll template this, I'll save this as CSS and then press save. Oh, the something is coming, you press OK and then you close the CSS DWT. Then to load that, you can import file new and you go to that folder UOM, then you load this CSS DWT. Continue with the current command. Okay, now you can save this as in your folder day 2 as CSS, right? Then press save. Now what I'm going to do is I'm going to switch on the surface in our profile drawing, and I'm going to select everything like this, edit, copy, and then I'll go to the CSS file and I'm going to save it there. But remember, you can't save it anywhere. You have to save it into the original coordinates. Now it should be somewhere there. Here. You don't want to change anything here. But remember one thing. Please focus your eyes here. 150. That is the scale, right? If you go to profile and see, it is 1 to 1000. Here CSS, it is 1 into 50. So that is usually the scale that we are going to create cross sections, right? So this profile thing is finished. If you want, you can switch off the surface, no display, apply, OK, and then you can save the drawing. And why? Yeah, sometimes this can come. An error occurred during save. We recommend that you run recover on the drawing. I don't know what is the problem. Sometimes this comes. So you save it as say profile 2 or something. Otherwise, whatever that you have done may be gone. Some bug. Okay. So now I am going to do the cross section. For that, Civil 3D is giving you some beautiful option. That is, they are going to create a cross section, a typical cross section, using this something called assemblies. Okay, something called assemblies. So you are going to create your typical cross section using their tools. After that, you are going to run it along the then you are going to create a corridor with that, and then you are going to run that assembly along that corridor to create cross section. So we'll do that quickly. You know, we have very limited time, so please pay attention. So we'll go into sections. Now corridors, create assembly. So I'll give a name, CSS. Assembly type should be undivided count road. That means your road is your road does not have a center median, and it is count. It is not a flat road, right? Assembly style, we'll go to RD assembly. Here the code RD finish A9, right? Press OK. Then usually we put assembly somewhere near the profile view. There's nothing on that because otherwise it is very small, we can't find it. Okay, I'm just drawing a circle also, right? So this is your assembly. Now you have to get from here. I'll remove this one. General, tool palettes window. Earlier you took tool space. Here I'm going to take tool palettes window, right? Then can you see some cascade like thing here? If you right click there, and if you get rehab, oh sorry, here rehab, there is something called overlay mill and level 2. That is your existing role. Okay, you are getting overlay mill and level 2. Select marker point within assembly. So this is the marker point here, but you will have to correct the parameters. You go to sub assembly properties and then go to parameters, crown point offset. That means whether your crown point is offsetting from the center line. No, so it is 0. Left sample point offset, that is your design line. It is 3.5. If it is left, you give minus 3.5. Right sample point plus 3.5. Left trim point offset, that is your existing node. We don't know how much is that, but usually we give minus 2.5. This is just for the drawing, right? And right trim point offset, that is 2.5. Left overlay slope options, that is outside lane of super elevation. That means how I am going to decide left side slope. So we ask them to take outside lane super elevation. If you don't give that to me, if you don't give that to me, what is the slope that I have to take? In Sri Lanka roads, you have minus 2.5. Then right is also same. You have to take outside lane super elevation, and if we don't give it, you have to give minus 2.5. So this slope tolerance should be 0. Okay, because it's difficult to explain what is slope tolerance is. So that means if you are going to give it something like that, so it is going to tolerate the slopes depending on the requirement. So you,
Recording stopped. Recording in progress.
yeah, so we usually do not advocate software to decide that for us. That is why we give, okay, don't worry much about it. Slope tolerance is, software is not going to decide anything. Only the design engineer is going to decide the slopes and everything. Use profile, here you have to give use profile, otherwise use minimum clearances. It is, now the software is trying to have a profile, software is going to have a profile to maintain a minimum, what, a minimum clearance. Now if you are having say 40 millimeter wearing course, 60 millimeter binder course, and then what did I tell, 200 ABC, your minimum clearance is 200. Okay, so you are go, because then we ask, okay, keeping that minimum 200, you create your own profile. Okay, if you give here use minimum clearance, it will create its own profile. We don't want, because we have already created that, and that is not pretty correct, right? Because it is giving just a line that is everywhere it is greater than 200, so it does not consider about, you know, the curve length, the case or whatever. That is just a rough guideline. Okay, that is why we use profile. So sorry, so the minimum clearance is zero point 0.2, y ABC is zero point 0.2, overlay depth is 60 plus 40, that's 100. So we press apply, press OK. So maybe it's not showing very properly. Yeah, so right, then our existing road is created. Now we'll go to here, you know, there is something called lanes. We'll go to lanes, we'll take we have to take lane outside super multi-layer, lane outside super multi-layer. So select marker point within assembly, this one. So again we have to correct this one. You go to sub-assembly properties, and we give this, since it is RHS side, we give it as R. So the parameters are side is right, insertion point is not crown, edge of travel way, crown point on inside, that means whether the crown point is falling inside, no. Width, so if it is 2.5, then this should be 1 meter, right? Because the lane width is 3. Now here this is the existing road, this is the widening section, so the width is 1 meter, default slope is minus 2.5, and super elevation slope is right outside lane, and lane slope direction. So what should be the slope? That is away from crown, that's okay. Pave 1 depth, pave 1 depth is varying depth 0, and pave 2 depth is what, binder. There is no pave 3, that is the regulating course, we don't use, though we don't use. Base 1 depth, that is ABC plus 200, there is no any other base. Sub base depth is 300, we don't have any other. Okay, now if you really want, now you see it is not coming very nicely, we can change that. These are some advanced things, but I'll just show you, right? So you can go to edit assemble style, and now you have to go to here, assembly properties, and you go to codes. Here this is RDA finish A9, You can try to edit them, and you go to shapes and check here, level. So you have to change it as level is ABC not, and then pave 1, pave 2 should be pave 2, you have to correct them, right? Okay, and sub base is type 1 not. Now you have to import codes, right? You have to import codes from here and check whether they have not been given. Base 1 is standard, so you have to base you have to give as base node. These are some advanced things, right? So you don't worry. Base 1 also ABC node, but if I don't say these things, it's not complete, right? And the level, okay, mill should be pave 1, and overlay pave 1, pave 1, pave 2, pave 2. Sub base is type 1. Here sub base 1 is pave type 1 node. There are no 2 3 sub bases, right? So if you apply and okay, here you can see that you are showing pave 1 differently, pave 2 differently, and then this beautiful ABC layer, and this uh, what you call the sub base, right? Then okay, so what you have to do is you have to mirror this into the other side. You can select this and here mirror, and you mirror that into the other side. So here, here 3.5, so this is your lane width, right? Up to 2.5 it is the existing road. After that there is 1 meter, right? That is in the widening section. But here you have to change something. Even though you mirror subassembly properties, name should be L, and then parameters side is left. Here okay, edge of travel, these things are okay, but super elevation slope should be left outside lane. Press apply, okay. Then you have to get the shoulder. Okay, so you go to shoulders, and then you go to shoulder vertical sub base and select here, and we'll correct them also. Sub assembly properties, shoulder vertical sub base are parameters, side is right, paved width is our one 1.5. Use super elevation slope, you have to use right outside shoulder. Shoulder slope direction is away from crown. Default paved slope is minus 2.5. So you don't touch this unpaved link treatment. That's again another thing that in advanced thing. Unpaved width is 2 meter. Unpaved slope is minus 4%. The maximum breakover also uh, don't touch. That is a some complicated. I don't have time, so you better ask Professor Vasant. Okay, he has a good explanation on that. What is the maximum breakover? Then pay 1 point, pay 1 is 0.040, pay 2 depth, that is 0.060, base 1 depth, that is 0.200, sub base depth 300. You press apply and okay. So this is your what? This is your paved shoulder, and this is your unpaved shoulder. Now I am going to give cut and fill, that is called daylight. You have to use daylight multi-intercept, and you are going to put it here, and then you can change subassembly. You go to subassembly properties, you don't want to change the name, so parameters, you maybe cut slope we put into 25 into 1, and fill slope 1.5 into 1. Okay, so if it is a fill it goes like this, if it is a if it is a cut it goes like this, if it is a fill it goes like this. So you select these two and then mirror and come here, right? So if you select this shoulder, you can select sub assembly properties. You have to change the name L, and parameters, side is left, use super elevation slope, left outside shoulder. Okay, there's nothing to change there. Press apply, press OK, and you close this one also and save the drawing. So this is your typical cross section. Okay, now these are, highly automated things, right? So but you have to learn how to do that, that's all, nothing else. But there is no, you don't try to think what is the logic of that, because there is no logic. There's software, that is how they are going to do that. Okay, so don't worry. So we'll create a corridor, create corridor. So you are going to give a name, css. Corridor style, usually it should be basic. So alignment should be DCL. Profile is the one that we created. Assembly, it's CSS. Target surface is existing ground that we created in the beginning of the lecture yesterday, right? So press OK. Right there you have to use the frequency. Along tangents you are going to create the corridor in 10-meter intervals. Okay, in the curve also it's 10-meter interval. Along spiders also 10-meter interval. Now they ask, at horizontal geometry points, do you want to have the corridor? There is no point, right? Because we have taken the cross section levels only in 10-meter interval. So whatever, everywhere it should be 10 meter. Okay, so don't take, because no point, there's no accuracy. Whether you want different corridor creation in super elevation critical points. If you have taken the levels, then that's okay. If you haven't taken, there's no point. So give no. Along vertical curves 10. Vertical geometry we have not taken. High low points we have not taken. Offset target geometry no. Offset no. So press apply, and then you go to targets, and here you have to give the targets. Now please pay a bit attention here how to give targets. Okay, crown point offset is the crown alignment, that is here DCL. You add it here, press OK. Left sample offset, that is left edge of the lane. So that is, you remember yesterday I named it as DLHS. Press add. Left trim, that's the problem. So we don't have the trim. Trim is the existing one. We did not create what? We did not create, the we did not create the existing alignment. But don't worry, we can create it later. So we'll go to right sample offset, that is DRHS, and right trim we didn't create yet. With target they are asking R. Okay, lane outside super multi-layer R. You remember this one? That is the edge of the right side lane. So that is DRHS. Here D left outside super multi-layer L, that is DLHS. End of the lane width. Or sorry, so you can delete it like this, right? With target this one DLHS, and paved with target, that is HRHS, that is hard shoulder, HRHS. And here shoulder vertical subbase L, that is HLHS. Okay, now press OK, press apply. So it is asking the corridor definition has been modified and needs to be rebuilt. What do you want to do? Rebuild the corridor. So it is being created. Okay, okay. Now if you go to your here, this is your corridor. But the problem is we did not put our existing alignments. So you want to have polylines of existing targets. You remember we created these polylines in the surface creation. So you can get them. You can open your surface, surface drawing, and you can switch off this surface. Here you remember we created some two lines like this. So you can create alignments from them, no harm. How you are going to do that? Now please pay attention. Alignments, create alignment from polyline. You select this one, double enter, and give the name ELHS and site. It doesn't matter. You you don't want to have labels, conversion options. You uncheck everything. So here is your existing tag LHS. So we'll create existing tag RHS as well. So alignments, create alignment from polyline. Select this one, double enter, and ERHS, existing RHS. So no, site okay, alignment style okay, no labels, uncheck everything and press OK. So you can select these two alignments and cut them. Okay, go to CSS and edit, paste to original coordinates. It is pasted. So sir, in surface you don't want to do any changes. You don't save the changes and remove them. And now again you can go back to your under the tool space. Here is your corridor here. So what you can do is you go to properties and then go to parameters and then go to target. Here left trim is not filled. Now you can fill ELHS, and right trim is not filled. You can fill ERHS. Okay, now again check whether these are okay. Crown offset target DCL okay. Left sample, that is the lane width DLHS. Left trim, that is the existing lane width ELHS okay. Right sample, right lane edge RHS. Right trim offset ERHS okay. With target they are asking for the right hand side one DRHS. Lane outside super here with target they are asking for the LHS side okay. Paved width they are asking for the RHS side HRHS. Shoulder vertical subbase they are asking for the HLHS. Then okay. Then press apply, rebuild the corridor and okay. Right, now save the drawing. Now once you create this corridor, you have to do something. What is that? You have to go to this corridor and there is a small modification you have to done here in surfaces. You press this create a corridor surface, and while the data type is links and specify code is top, you press this add button and press apply and OK. Rebuild the corridor and OK. Once you have done that, you will see another surface is created. So that means earlier we had the existing surface. This is the design top surface. Okay, with your design, this is the design top that you are getting. Right. Now this is your corridor. Now we are going to cut this corridor into many segments in 10-meter intervals to create the cross sections. That we are doing using sample lines. Create sample lines. Okay, you press create sample lines, select an alignment or press enter to key select from the list. I'll press enter. You get DCL. We are always using the design center line, right? Then you will give the name SLG sample line groups 1. Here it should be RDA sample lines. Sample line label style should be RDA name and section marks. Okay, and here in this middle one you have to change that style into RDA finished A9. Okay, now press OK. Once you press OK, there comes another one. sample line tools, you press by range of stations, and you have to give these details. Do you want to cut it from the alignment start? True. To alignment end? Yes. Snap to an alignment? No. False. Width. So what should be your cross section width? Usually we give 15 meters. That depends on the road width, right? And here right one, snap to an alignment false, which should be 15 meters. And sampling increments, everywhere we give 10 meters. Increment along tangents, increment along curves, increment along spirals, because sometimes if you want, sometimes along tangents you can give in 20-meter intervals, and along curves in 5-meter intervals. If you want, you can do like that. Additional sample controls, do you want to have one in your range start? True. At range end? Yes, true. Press OK, and then we press enter. Once you press enter, these are the places that your corridor will be cut to create cross sections. Okay, right? Now if you want to know where these sample lines are, you go to the sites, site design, alignments, center line alignments, here DCL, you right click and go to, no, you expand it. Here sample line groups, here this is SLG1. If you want to check that properties, you can go there and check sample lines. These are sample lines that we have created. Sections, section views, material list, there's nothing. Okay, right, now we'll create cross sections. Okay, save the drawing. Then you go to sections, create multiple section views. Here alignment is DCL, sample line group is SLG1. Remember we created that. Station range is automatic. If it is say something like 50 kilometers, usually we have only 2 to 5 kilometers per one page, one file. Okay, so then that's okay. Right, then we give a name as say S1, and then section view style should be RDA, road section A9. You go to next, and you can have it as a draft. Okay, group plot style, RDA plot by page. So that is one thing that we have created. Now if you want, really you can create another one using here, create new, copy current selection, read current selection, like that. Okay, so you go to press next. Here offset range minus 15 to 15, that's okay. Elevation range, that depends upon the elevation, so we can't change that, right? And then section display options, usually we untick this one, otherwise later we'll have to untick that. Then you go to data bands, we'll go say this is one that we have created, EMK final, like that. You can have whatever you want. Here I'm going to show offsets, FG elevations, EG elevations, so it should be EG, right? EG elevations should be existing ground, understood? FG elevations, CSS 16 is the surface that we created using the corridor. So that is the FG elevation, because that is not only in the center line they are giving, right? They are giving in the edges, and then maybe somewhere in the edge of the lane, edge of the hard shoulder, and edge of the say soft shoulder, like that. So they can give. That is why we create a surface using the corridor. Otherwise the center line will suffice. Then this is level. There's no L here. So surface 1 minus surface 2, EG. So that is going to give the level difference everywhere. Okay, so we'll go to create section views, identify section view origin. I'll put it here. Now the cross sections will be created. Can you see here? These are the cross sections. Right, if I take here, you see here the problem is, now you know, just think that you are doing an actual project. Now the problem is here, this is the fill. I'll save it first, right? I'll just describe what are these things. This is the center line. This is the existing road. Okay, after that this is the shoulder, because why there is no widening section, because road is wider than the existing road is wider than the design road, because we just got 3.5 something like. Okay, so here you see in the center fill is 369, but when you come there it is 262, that is 40 millimeter reduction. So that's, we can't allow that if you are going to do an actual project. So depending on that you will have to change your profile, so raise the PVIs. Okay, so can you see very beautiful cross sections? That is, being beautiful is something, but now again here you check here. Now here in the center line it shows 298 fill, but what happens at the edge, something like say lesser than 50 millimeter. Okay, so we can't allow these things. That is why we are going to create cross sections everywhere. You have to create the cross sections to see the actual picture, what is really happening in the field. Otherwise you think, okay, so you may be really happy here, I created a good profile, say it is only 298, just 2 millimeter gap, so you give that to site, and then they come back and say, "Ayo, sir, what how can we do that?" They are, so it goes and touches the existing touch. There's no fill here, no ABC fill. So how can they do like that? That's wrong. So you will have to raise this. Okay, so that is why the cross sections are very important. And there is another thing usually we do using this one, quantity calculation. So, but unfortunately we don't have time, and of course there's no point, because we have to understand these things very first, and then you have to practice them and everything. Okay, so right, then that is all I thought to cover today. So if you have any questions, could you please ask? Yeah, don't stay silent, right? Please come forward and ask me any question. Now somebody has sent me an email, no, not email, an SMS, I think. Yeah, one. Yeah, he has sent me an email, so I don't know who is that, but anyway, I'll send all my details there, including my, this the booklet and everything. So you can get it from him. So do you know who sent that? I don't know whether somebody sent individually, but anyway, it is better if he was the batch rep or something, so you can share. If the batch rep didn't send me the details, please send me again. Okay, so I'll share my book and then these drawings and everything, so you can try it yourself. Okay, yeah. So any questions that you're having? Yeah. So if you don't have any questions, then we'll have to wind up. Yes. Right. Then shall we wind up? Okay, then thank you very much for joining. Maybe we'll meet in the industry or in some other places. I don't know, maybe in your seminars and everything. Uh, right. Thank you very much.